Hi everyone, in this video we will learn about hydrates. Hydrates are the compounds that have the natural tendency to absorb moisture or water from the air. Okay, so this compound will be trapped between water molecules. So I have water molecules all around it. And this is a natural tendency of this compound that it will be surrounded by water molecules. So if it is surrounded by 5 water molecules for an instant, according to the example that I wrote here, I will say I have CuSO4, which is, I hope you understand the name, it is copper 2 sulfate, and I put a dot here, and it has 1, 2, 3, 4, 5. So 5 water molecules. Okay, it is not part of the chemical formula, it is attached to it. Okay, you have to understand the difference. Okay, so it's a compound that has a natural tendency to absorb water, so I will say it is copper 2 sulfate. Okay, and when you write the name, it's 5 water molecules, so I'll say pentahydrate. Okay, where hydra means water. That means it has absorbed 5 water molecules. So I have sodium carbonate, okay, and I have 10 water molecules attached to sodium carbonate. You see I use a dot. This dot does not mean multiplication like in algebra. We are going to add the mass if we have to add if we talk when we talk about masses. But right now it is sodium carbonate, and 10 means deca, so decahydrate. This means that 10 water molecules are trapped in each formula unit of sodium carbonate. Again, it is not a chemical combination, it is a physical mixture. So it is not bonded, okay? They are just attached to it. I can easily heat it and evaporate it. So prefixes used in for hydrates, same as for covalent compounds, you know, mono, di, tri, tetra, penta. So this is how we name them. The water molecules are trapped inside the ionic crystals, but they're not bonded to them. And when you heat it, it can easily evaporate. So let's say I have a hydrated compound, which is 2.50 grams. So this 2.50 grams also has some mass of water, you know. So this is the initial mass of my sample, okay. And then if I heat it, so the water will evaporate, and whatever is left is the anhydrous compound. So anhydrous means that is without water. Okay, this is without water. So if this was with water and this is without water, then how do you calculate the mass of water? I hope you understand that. It is simple enough. That how do you calculate the mass of, water? You will say 2.50 minus 1.59. That gives you the mass of water. And then that mass of water divided by the total gives you the percentage of water, and the 1.59 divided by 2.50 gives you the percentage of copper sulfate. Okay, so molar mass of water is 18.0 grams. Okay, the molar mass of copper sulfate is this, and I can easily calculate the formula of hydrate. So go ahead, and I want you to calculate the moles. You need to calculate the moles of each, because in this compound, let's say I was talking about Na2CO3 decahydrate. Okay, I have 10 moles of water and 1 mole of sodium carbonate. So I want you to calculate the grams of water, which you got right here. You got the grams of copper sulfate right here. So convert the grams into moles, and that tells you that how many, what is the value of X here. So this is how we calculate the moles of or grams of water. So here is the example. So when I separate it, I have 100, this is, I converted it into moles, and now which is the smallest number? This is my smallest number, so I divide both answers by that smallest number. Okay, that gives you the 1 mole of copper sulfate have 5 water molecules. So I calculated my X right here. So this is how you calculate the hydrated compound. And again, it is not a homework, it is your classwork. You need to work on page number 340 and 341, and we will have a quiz later on. So don't worry about this right now. We will just do this as a classwork next class. So that's all about hydrates.